Hello, this is Adventurous Man, and I'm on to the next experiment. Now, I want to do this reasonably quickly so that I can work out what is the best way of putting these washers together as fast as I can to put a system into my truck. Now, at the moment you see the hash marks. That's because the insides of these washers have been scored with sandpaper, about 60 to 80 grit. And it's going pretty well at the moment. It's been going for a few minutes now, and I'll be testing the gas output very shortly. The amperage has stayed around about 1.25 amps, which is less than the 1.6 amps of the other ones, which is disappointing because apparently scoring is supposed to increase the surface area by as much as 40%. So either I've done it wrong, or because I've got it so close together, it's not dictated by the surface area but perhaps by the circumference. Something that's only just occurred to me now, which is also quite interesting. So that opens up some possibilities. And I'm running this at 3.3 volts, which is hooked up to the orange there. As you can see there, the orange. Okay, now let's get my stopwatch and get this started, huh? Now, let's see. See the bubbles there? Or can you? You just see it through the glow there, see? Anyway, pop the top on and start the watch. There we go, and she's off. Okay, now I came up with three other different ways of putting the washers together. I can score the surfaces, the inside surface, the working surfaces, which is supposed to increase surface area, therefore increase current density, yes, and therefore output. I can put them back to back so it's shaped like that, where on the circumferences the area distance is greater than it is in the centre, and then I can do it the other way. And the reason why I've got these options is because it's the way, this is how washers are made. They're stamped out, so the edges are curved, so it's not perfectly straight. This is something that I may or may not be able to use. It may be that I just have to use them back to back as I've been doing all along anyway. This is actually the penny washers, and these are about 32mm diameter if I remember rightly. I'll have to show you the calculations I've made for the surface areas and the difference between the two, but it works out that it's not quite, but these penny ones have just about double the surface area of the smaller ones. Something that would be a great boon to me. Okay, that's assuming that I can get these producing enough without too much current. Ideally what I want to do is have them all running at about, I don't know, maybe 2 volts I guess, or maybe 3 volts as here, because it doesn't seem to heat up the water too much with the single washers, so I'll have to try it with the setup that I've got here, which actually turns out to be 11 pairs. Okay, now see how we're going at the moment. Going 2 minutes, almost 2.5 minutes. We're not even halfway there by the looks of it. Still got a wee way to go, just a blip at a time. This is of course assuming that I haven't developed any leaks. I may have developed some leaks. That's interesting. No, I don't think it would matter, especially since it doesn't appear to be bubbling there either. So I don't think it's something I have to worry about at this stage, though it does prove that I do need to get a better system for in there. And ideally what I'll do is I'll have something that I can bolt in so it's tight, so I can handle the forces that I put it through when I'm bending it this way and that. It's just not tight enough, not strong enough with the sealant alone, which to be honest was expected really, but you never know, that you've got to try these things out. Now it appears the rest of the system seems to be pretty tight, or tight enough as it is. 3 minutes 50, getting close to 4 minutes. Now it looks as though we might be at maybe, I don't know, a guesstimate of about 40 mils perhaps. So we're getting there. No, I'll go to 50 mils. It won't be accurate, but it'll give me, I've got a definite measurement to go with, rather than a total guesstimate, which could be totally wrong. The current hasn't really changed, so the temperature hasn't changed too much. The ambient temperature is around about 20 degrees Celsius. So 3.3 volts for a single washers and a cup of water seems to be about right for holding its temperature really, by the looks of it. At 5 volts it will definitely start to heat up and will be noticed, I'm thinking. But I am very surprised that the scoured surfaces hasn't done what I expected, which is improved the output. Should have improved it by almost half, almost really, or at least by a quarter. Okay, very close, very, very close. Okay, there we go, 5 minutes 14 seconds. Okay, now I've noticed that the computer thing here, and the program I'm using, it's actually not accurate enough and seems to round it off to 4 decimal places. Now I can probably fix that, but what I'll do, see, I'll use a calculator and put in some of the figures myself. 1.25 amps, took 5 minutes and 14 seconds. So 50 ml of gas. 1.4. Okay. Better turn the sucker on. So that's 0.05 divided by 314, which is 5 minutes and 14 seconds, equals 1.59 to the minus 4. So that's 0.00001, we'll say 16. Round it off. Now multiply that. 16. Get rid of that, see what the result gives. Delete. Enter. There we go, that's better. That's more expected. Okay, 0096. So I'm not quite doing a milliliter per second, or let's see, times 60.0. So doing 0.0096 liters per minute. Okay, so that's 110. So I'm almost doing, well, I'm doing 9.6 milliliters per minute. That sounds pretty bad. But let's do the theoretical. No, don't have the time for that. I have to sign off. So this is Adventurous Man signing off.